Hello, everybody. My name is Kouassi Mensah. Welcome to this session about building and deploying a My To-Do list application using ReactJS, Java, and the Oracle Autonomous Database. Here is the agenda. I will introduce the application. What is the to-do list ReactJS application? Then I will describe what is the full stack and what is the cloud native architecture. I will describe the architecture of the application and explain why it is a full stack and cloud native application. Then I will describe the various components that we use to build the application and how they mesh up, how they, mesh up, as I said. This is our safe harbor statement in case I mention some future functionality. Okay, this is a simple My To-Do list application. As you can see, it has a window where you can enter a new application. You can put whatever you want, something you would like to achieve. And then you click the add button. When you click the add button, the item, the to-do item will be listed here, okay, underneath. Like take my car to garage for maintenance, for example. And then you click done. When you're done, when you have performed, when you have completed the to-do item. So when you click the done, it will go down the done items. This will join this list over here, right? So I was preparing my presentation for Database Live, and that was done. So I clicked done and it came here. And I can leave it there. I can add future, or if I don't like it, if I need to do some more work, I will click undo. It will go back to the list here. If I don't want it at all anymore, I can just delete. So that's it. It's a very simple application. Okay, so what is behind this application? What is the architecture that we're using? And here is the architecture and the components. So it is a full stack, which means it has a front end, a mid-tier, or you can call it the backend, and the database. It's a complete full stack, end to end, from bottom to top or top to bottom, whatever you like it. Okay, so as a front end, the UI, we are using ReactJS. So we're using JavaScript, React JavaScript. Okay, that's front ReactJS. I'll describe that in a moment. This ReactJS component is making calls, is making REST calls to the backend. And the backend in this version of the application is made of Java. We're using the Helidon framework, which is a framework for building microservices. We are using the Docker container. The application will be containerized, deploy in a Docker. The Docker image will be deployed over Kubernetes, but it will be stored in the container registry. So you see all those components I will describe in a moment. And then from the Java application running in Docker deployed over Kubernetes, we're going to access the database. The database is deployed on the Oracle Cloud infrastructure, and it is the autonomous database. So those are all the pieces that made up this application. Now let me zoom into each of those. Okay, I mentioned that this is the cloud native. So what is the cloud native foundation landscape? This is a foundation where all the cloud vendors contribute. So you can see components from all the vendors here. And for example, so it's too tiny. You cannot read each of those, but you can read the top. You can read the categories. So we have a database category, for example, and you see Oracle is here. we have streaming, messaging, etc. So there are many, many, many components. We have service mesh, we have API gateway, and I put a red arrow here because it's part of the component that we're using to build the application. And you have some other components like scheduling and orchestration, and this is where Kubernetes fits. So Kubernetes is part of this category. And we have container registry here. You see here, right? Okay, so these are the components of a cloud native computing. And all vendors are trying to contribute or use components from this same platform. Okay. Now let's talk about the REST APIs. The REST APIs we are using for this application are described at this location, sorry. At this location, they have been described, and the REST APIs are implemented by the backend component. So the React application does not implement the backend. It only makes calls to those APIs, right? So for example, when we do an HTTP GET /to-do list, it will return the list of to-do list items. When we do HTTP post /to-do list, it will add a new item to the to-do list. So when I click my button, add a new item, the HTTP post is being issued, that call. I can do get to-do list with an item ID. If I want to find a specific item with its ID, I can do an HTTP put, etc., HTTP delete. So those are the 5 REST APIs that we are using for this application. So this is the anatomy or the structure of the React FrontJS application. So we are using React 16.13.1, which is very recent, I think. And we are using what is called functional components. So functional components are not classes. So they are different from classes components. So the problem with functional components is they don't have state. So if you need state, you either turn them into classes, and then you can use state, for example, this.useState, or you use state hooks. State hooks are new things in React. I think they come in 16.8, I think. Okay, anyway, it's not that old. And what the state hooks provide, those are special functions that let you hook into React features. For example, if I want to show you a spinning wheel when I'm loading or when I'm inserting something, that's state, right? So I'm gonna use state, and I'm gonna specify a function. I'm gonna create a constant, a variable, etc. I'll explain in the next slide. I'm just telling you that state hooks are mechanisms to inject state into a function component without turning the function component into a class. So the application is bootstrapped using create React app. This is a bunch of scripts which let you run the application locally, okay? And then the application makes calls to the backend via the API gateway endpoint. So the API gateway endpoint is the endpoint where the API gateway is listening. And okay, if you come to the workshop, and I encourage everybody to join the workshop later after this session, you will be able to configure the API gateway yourself. You know, you will be able to configure every component that we've been describing here. Okay, so that's sort of the description, and you can see here that if you clone the repository, the GitHub repository, there is a front-end folder. In that folder, there are different subdirectories. In the source subdirectories, you can see this is where the application component is. This is the application component that we will be using, the main component. It also renders another component called new item.js. Okay, so that's pretty much the architecture of the front end. And you have the style sheet, index.js, index.css, etc. And this is a screenshot to show you a fragment of the application, and you can see we're importing React. We're gonna use those state hooks, use state and use effect. So here is an example. You can see that the state hook, the use state hook is being used here. So what it does, it takes an initial or default value, which is false, and then it returns a variable, the state, the current state, and a function to update the state. So we use this when we are waiting for the server to load content. So we show you a spinning wheel by using that. Other example is we're using this when we are inserting into the backend and it's taking some time. We use the spinning wheel. I can tell you I've never seen those spinning wheel when I'm playing with the application because it was so fast, there was no need to show you the spinning wheel. Okay, so that's sort of a quick summary of the front end. Now let's talk about the backend. The backend is made of the API gateway, the Java Helidon, the Docker container, the container registry, and Kubernetes cluster. So I'll go over each of those. API gateway, it is a front end to your cloud service. You can use it to protect your RESTful services and other endpoints. And people use the API gateway also when you are doing application modernization. So you have a bunch of microservices or Lambda functions which are running in the cloud, but you also have your legacy application. So you make all the calls go to the API gateway, and the API gateway is able to dispatch calls to the microservices or calls to the monolithic legacy application. This is how people do incremental modernization, for example. So the API gateway is a very important component. So you need to define something called cross-origin resource sharing, CORS. Okay, in a simple term, it means you need to define which are the URL or server which can access the service. It's called the allowed origins. And then you need to define the method that those origins are allowed to invoke. And you see get, put, delete, post option here. And then, so that's the policy, and the API gateway enforces policy. But the API gateway is also useful to do metrics. For example, if I want to charge you, for example, for consumption, I can use the API gateway to do that. And it does logging as well. The backend is a Java backend, and it implements the REST API, and it's made of a few Java classes. And you can see here, there is the main Java, which starts and configures the main entry point. We have the to-do item.java, which maps the to-do item instance. It does a mapping to and from JSON. We have the to-do item storage, which store the item into the Oracle Autonomous Database. So this is the persistent sort of function. And then we have the app service, which implements the Helidon service and exposes the REST API. So if you clone the repository, again, in the backend, there is this Java folder. Under the Java folder, you will see those Java classes. Let me quickly go over those. So I'm here. This is my main Java class. You can see the main Java class. We are building the web server here. And then we are doing the routing by creating a routing here. This is routing here. It's routing to the Helidon service. This is the to-do item. Most important here is to notice this, there are getters and setters, okay? And you can see two functions, the mapping to JSON object, mapping to JSON, so mapping the item to JSON. And you also have from JSON. So we are getting a JSON document and we are converting into the to-do item. that we are displaying. And then we have the persistence function. This is a function to do the database access. So you can see we are getting the URL, the username, password, and we are specifying which is the data source that we're using. And you can see when we say list all, we are selecting from the table. This is the to-do item table, and we are just ordering by creation timestamp. So this will pull all the to-do item from the storage. You see here the get by ID. Get by ID will recoup an item by its ID. And you can see we are running a prepare statement, select ID, creation, blah, 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 where ID equals the value you specify, right? And same thing for get ID. This time we are not giving the ID, we are giving a text, right? Okay, then we also have delete by ID, etc. Okay, and this is the Java class which is implementing the Helidon service. Okay, so I'm not gonna spend too much time on this. Let me go back to the presentation. And once again, if you come to the hands-on lab, which is after the session, you can play with those. Okay, so next I'll talk about Kubernetes. So the application, the backend, Java, Helidon, is containerized, which means we produce a Docker image and it's gonna run in a Docker container. The container is stored in the Oracle Container Registry called OCIR. And then the image will be deployed, taken from the registry and deployed over a Kubernetes cluster, the Oracle Kubernetes engine, okay? And what you're seeing here is my Kubernetes service, the service to deploy the to-do Helidon application. And this is the external IP that I can communicate from, where the API gateway can route requests to the service, right? I'm using a namespace here, but if you are doing the workshop, you don't need the namespace. You can just use the default namespace. And then I am deploying 2 pods, so 2 instances. And that's because I'm not expecting that many people, but if you're expecting a lot of people, you can configure many, many more pods, for example, okay? So that's for the Kubernetes. And if you come to the lab, you will configure your Kubernetes cluster. Okay, this is the autonomous database. And as you can see here, we have a create table. It's only have 1 table. That table has the ID, the description, the timestamp, and the flag which says it's done or it's not done, blah, blah, blah. And we specify that the ID is the primary key. And it's a typical table, you know, to store some stuff, making sure that the ID is unique. That's why we say it's a primary key. And here we are generating the ID using some system sequence. So we are not providing an ID manually, right? So it's a very simple, and this is the content, the description of the item. So you have enough space to put whatever you want as an item, for example. Okay, so the communication, we are getting the URL, we are specifying the URL, the JDBC URL. We are specifying the user, we are specifying the user password through a YAML file, but this is just a detail, you know, it's a way we are using this mechanism to make it easy to communicate to the Java, because, for example, if I switch to another database, for example, how do I change? I'm not gonna hard code those things into my Java code. That's why we're using this mechanism to communicate what is the URL, what is the username, what is the password, right? So that's the database. Right now we are using just using a relational, but you can imagine that we could use a JSON document. The autonomous database supports JSON, and this is something we've been promoting, the converged database. The notion of converged database means it's the same engine, but it can support multiple data models, relational, text, JSON, XML, etc. If we were to have a full-fledged microservice architecture with a lot of microservices and each of them using their own specific data model, well, we will specialize the autonomous database cloud services, for per each data model. For example, you could use the autonomous JSON to store just JSON. For example, I'm giving this as an example, right? So yeah, that's pretty much what I have on the architecture, the components of the application. Now we're gonna go to the Q&A session. I put here the URL, the GitHub repository where you can clone you can get the code, all the Java code I show you, all the JavaScript code I show you. Those are in this GitHub repository. And as I said, if you come to the lab, you're gonna get to build and deploy the application yourself. So let's turn to the Q&A now. So the question is, for the backend, can I use Micronaut instead of Helidon? Yeah, good question, good point. Yes, you can use any microservice framework, not just Helidon. You could use Quarkus, you could use Spring Boot, all those microservice frameworks. So we are using Helidon because this is the one Oracle has been promoting. So that's the only reason why I'm using Helidon. So the answer is yes. So the second question I'm getting is, if I want to use JSON data model, should I use the autonomous JSON database instead of ATP? And that's a very good question. And so let me explain. The ATP is the transaction processing variation of the autonomous database. So for example, we have autonomous data warehouse for data warehouse, and we have the autonomous JSON for JSON only. So you exclusively using JSON to build your application, you can use the autonomous JSON database. But if you want to use multi-model, for example, you want to use not just JSON, but also relational and also some other mechanism. For example, you are building a rich catalog. Rich catalog has text, photo, JSON, images, etc., etc. In that case, you would either use the autonomous transaction processing, which can support multiple models, or you have multiple microservices, and each of those services use a specific configuration. So the short answer to the question is, yes, you can use the autonomous JSON instead of ATP, but ATP also supports JSON. So depending on what you want, if you exclusively want JSON, then go ahead with the autonomous JSON service, cloud service. Thank you very much.